Wilson, today we will be getting into networking, where we will discuss virtual private cloud, subnets, and gateways. So, let's dive deep into it and know what are today's learning objective. We will be introducing VPC, so building your private, uh, say, island right in AWS Cloud. So, uh, we will discuss subnets. What are subnets? What are public and private, right? Subnets. We'll talk about gateways like internet gateway. So that is actually bridging the gap between your VPC and the world. So that is making your resources connect to internet. Then we will talk about routing, right? How your traffic is getting routed, how they are allowed to actually access, right, these gateways to connect to the real world, right? The internet. So let's start. Section 1, Introduction to VPC, the fundamental layer of AWS networking. Now, the concept of VPC is very, very important, right? To understand it in depth, right? Because most of other resources that we are creating, right? Critical say resources they are part of, right? Are VPC. So when you are actually creating your database also, right? So your database is also living inside VPC. Right. So you need to know how to actually segment, right, that a private network of yours. What is Amazon VPC? So if we say, right, the acronym, right, the full name is Amazon Virtual Private Cloud, right? So it is a logically isolated section of your AWS cloud. So definitely, when we talk about AWS, when we talk about Azure, GCP, right? These are all public cloud, right? These are all public cloud platform. Now, anybody, right, can actually create their account and access, right, these cloud platforms. Now, definitely, how you would, right, keep your resources separated, right, logically say separated from any other user, and the answer is by creating, right, your isolated, right, space in the cloud, and that is what your VPC, right, allows you to do. So it allows you to create that logically isolated section, right, for your resources, where only you, right, control everything within that, right? You define who can access those resources, who cannot, right? And who, right, you can actually access from that VPC, right? So it gives you, right, complete control over your IP address range, the CIDR, classless interdomain routing, right? So you can select what will be the internal, right, IP range, that is the private IP range that your resources will have. So say how many devices you want to have right inside that VPC, how many hosts, what will be the network, right, portion or network part of that IP. So that range you can select for your VPC. So you can create subnets, you can divide that, right, VPC into multiple segments. So again, that will be right in your control, that okay, if you want to divide say uh, the VPC right into symmetric say sections, right, segments, you can do that. If you want asymmetric, you can go for that also, where maybe in one segment, right, you maybe have 1000 IP, maybe in another segment you just want, right, maybe 500 or right IP. So you can do that. But again, I'm just rounding these figures. So we generally do not get right round figures like this, right, whenever we are actually creating subnets or the networks, right? So but yes, you can control that, right? You can divide that network into, right, small segments to better, right, manage your uh, say hosts, right, in that network. So you can configure your route tables. Now, yes, again, where, right, your traffic will be routed, what resources, right, it will connect, right? So that you decide, right? Because you have complete control over your VPC. So you are launching, say, we launched EC2 instance. So EC2 instance is getting launched inside VPC, right? And by default, in every account, right? Every account in every region, there is a default VPC that is actually being used, right? For your say launching your instances, right? Whether it is your database instance, whether your EC2 instance, right? So everything is getting launched inside your default VPC, right? Until you create, right? Unless you create your custom VPC, right? So then you have your network gateways, right? So routing, you are telling, right, through route tables that, okay, where, right, your traffic will be routed, right? And these gateways are actually allowing, these are the portals, or you can say the doors, right, that will allow your traffic to go through, right, and actually connect to the outside world, right? So VPC is by default, right, it is a private network, right? It is a private network. So if you are not having, right, say if you don't have any gateway, so it is a closed one, right? No one can come in and no one can go out. It is like that, right? So you need a gateway actually to access, right, resources outside your VPC, right? And then we will see, right, the security settings and everything. So the core concept of VPC, regional scope, very important, right? Your VPC is associated with a single AWS region, right? And spans all availability zone within that region. When you go for certifications, right, very important, right, question they generally ask, what the scope of your VPC? So it is a region, right? It is a regional service. And by default, for your AWS accounts, right, you can create 5 VPCs per region, right? Again, it is a soft limit, right? It is a soft limit of 5 VPCs per region. So if you want to create more than that, what you need to do is you need to mail the support and ask for limit increase, right? Because the soft limit can be lifted, right? So you can increase the number of VPCs, right, after getting a limit increase. Similarly, your CIDR blocks. So you define your VPC, say IPv4 address range using the CIDR notation, right? For example, say 10.0.0.0/16, right? So when you say in this example, right, if you go for this particular CIDR range, then this will give you around 65,536 IPs, right? So this is right what you can define. So if you need, right, in your network, you want to have, right, say close to 65,000 hosts, right, or maybe right, that is say your virtual servers. So definitely you can go for this range, right? If you want less than that, right, okay, again you can change, right, because here the range that you can define, right, it ranges from say /16 to /28, right, /16 to /28. So basically, if I tell you, right, in right, what this 16 represent here, so it is actually the network bits, right? It is representing the network portion of this IP range, right? This IP address that we are seeing here, that is 10.0.0.0, it is representing the network portion, right, of 16 bits, right? Wilson, how's your networking concept, network subnets and everything? So,
Yeah, I have basic knowledge, um,
okay,
but it's been a while, very long time, maybe 10 years ago. I did some networking
okay,
class, so
okay, okay.
I can't
So no
remember very well
problem.
again. But I have the
Okay,
basic.
no problem at all. Okay, so yeah. So why? Because the next session then we will be having right all the calculations and everything. Okay, so how to actually calculate them. So we will be getting into that because this is the
Okay,
most important part, right? So to understand how it works, what is it, right? Otherwise, so if I say, okay, 16 is representing network, okay, and the remaining bits again representing network, so a host, right? So that will be confusing. So we will have, right, a complete calculation for these. We will see different examples and then we will, right, we will create our VPCs, right?
sure.
So, yep. So here it is just right. It is representing the network portion of your net, right? Your IP, and based on that, right, we are getting here 65,536 IPs in this range, right? So the third concept, right, is logical isolation. So your VPC is logically separated, right, from other virtual networks, right, in the cloud. So ensuring privacy and security. So definitely, so as you are under control, right, of your VPC, so no one can, right? It is separated from any other users, right? VPC as it is a private network, right? You can have right the same say ranges for different right regions or say different users can have the same IP range, right? Because it is a private network. So again, we will get into all those things right during the calculations. So the virtual data center. So when we talk about VPC, it is think about right VPC as your own virtual data center. So instead of managing right all those cables and physical switches, you define software-based networking components. So we know in these data centers, right, we have everything connected, right? What we need to do is we need to define or we need to just go for the logical route, right, to connect these devices and access them, right? So it is a software-based networking that we are doing when we are configuring that VPC. So this abstraction allows, right, for rapid scaling global deployment, right, in minutes, definitely. So we can scale, right, whenever we want, whatever say network architecture we want, right? We can create them. We don't have to go through all those heavy lifting, right, of managing all those cables, connection devices, right, all those network devices. So we don't have to, right, take care of that or maintain them. So what we need to do is we need to define the logical, right, connection, right, of those devices. So global, right, deployment in minutes and enterprise grade security, right, without the physical overhead, right, for of your traditional infrastructure. So we don't have to right do all the heavy lifting or all those right overheads, maintenance, and managing of right network devices and components. We just define right the logical network and route right the traffic across that, right? That is what we do, and we scale it right globally, right, in this say without managing the data center. Section 2, we have subnets, right? Segmenting your network for performance and security. Now, when we talk about the VPC, it is a right, say it is the full network, right, that we are actually say allocating, right, for our resources. Now, Maybe in that network, as per previous example, 10.0.0.0/16, it was giving us approximately 65,500 IPs. Now, maybe, right, I don't want to manage, right, all of them, right, under a single umbrella, right? I don't want to manage all those IP, right, in a single segment. So, to manage the, say, resources or those hosts properly or more efficiently, what we do is we divide that into multiple segments. So when we divide that VPC in multiple segment, what we get is we get subnet, right? Or we generally it is the sub network, right? So VPC is our main network, and we are dividing, we're cutting that into small pieces, right, to manage our resources, right, in better way, right? So, what all, right, say improvement we will be getting if we are doing that. Number one, right, your network performance will be better, right? You don't have to manage all the resources under, right, one single segment. Instead, you can have, right, different, say, right, a number of resources based on requirement, and again, it will improve your security, right? Most important. So you can have different security, right, say permissions for different subnet, right? So maybe you just want to have, right, your publicly accessible resources in one segment, right, and your private resources, right, maybe that you're using for internal right, purpose, you can just keep it in a separate segment, right? You have your databases, you have your application servers, you just have them in a separate segment, right? So you can control the security, right, for them, right, differently. You can, right, you can attach different security, right, say configuration for your different subnet. Now, uh, from security perspective, say if someone is right, say they compromised your resource, maybe your web application that was running in, right, your VPC. Now, after say compromising your resource, the attacker, right, so their target, right, the next target is to move laterally, right, to move laterally from that device. They will try to gain access, right, to all other devices in that network, right? That is lateral movement. Now, if we are dividing that right network into small segments, so again they will be limited to that particular segment, right? So that is again, right, why sub networks or, right, these subnets are so critical, right? And here in VPC or in AWS, it is mandatory to create subnets, right? Whenever you define your VPC, you must, right, create subnets to actually access, right, your network, right? So a subnet is a range of IP address within your VPC. Right? Definitely, whatever range that you have selected for your VPC, your subnet range must be within that range. Right? So you divide your VPC into subnets to group, right, your resources based on security and operational needs. Right? So the key fact here is a subnet must reside within a single availability zone. Now, this is again very important when we said your VPC is having a regional scope, right? So your VPC is living inside a complete, right, region, but it is spanning multiple availability zone. If I draw here, say this is your region, okay, this is your region boundary here, and inside this region you have multiple availability zones. Say these are Okay, so say we have two availability zones. Okay, these are the two availability zone. Now, now, uh, here your VPC will have regional scope. You see, it will span multiple availability zones, right? It will span multiple availability zones inside that region, right? So the green one, right, the green border that you see, right, this is the VPC. It is crossing multiple availability zone. We can see we have two availability zone, right, one and two, right? Now the subnets are actually part of this availability zone. Okay, now inside that VPC, when we are dividing this VPC into small segments, or that is what we are calling, right, subnets, those subnets are actually limited to availability zone. So they have boundary of, or the restriction, right, of availability zone. You can create multiple subnets, right, but they are scoped within that availability zone. So here again, say in this second of AZ, we have two more subnets. So they will live inside the boundary of availability zone, right? The subnet must reside within, right, single AZ. It cannot span multi-AZ. That means the subnet cannot get outside, right, this boundary and right, say access the other, or say can spread, right, across multi-AZ. It is limited, right? The scope of subnet is availability zone, and the scope of VPC is your region, right? Is this clear, Wilson?
Yeah, it's
Oh,
clear.
great.
Yeah, I'm
So,
looking at the picture drawing, so it's make it clearer to me. Yes.
okay. Okay, great, great. So, right, this is the right scope of your subnet and the scope of your VPC, right? Now, here, when we are dividing, say, our VPC into multiple segments, right? Generally, you will come across, right, these two terms, right? Public subnet and private subnet. Now, public subnet, right? Say here we created four subnets. Okay, the blue ones, right? These are the subnets. Say we divided this VPC into four subnets. Now, say let me call the first, right, two here in this availability zone as public, right? You just consider them as public, and here in this other here let us consider them as private, right? So uh, the public subnets generally they have direct internet access, right? So that is why we call them public subnet, right? Because they have internet access, right? But on the other hand, the private subnets that we have, right, they do not have internet access, right? That is why they are private. Now, by default, when we are actually creating subnets, right, they are not public or private, right? Or we can say they are all private, right? Unless we make it public, right? We can say they are all private because by default they do not have internet access, right? So we need to actually provide the internet access and make it public, right? So only name will not make it public. So okay, this is my public subnet. I just named it. No, the name will not make it public, right?
Okay.
Yep. So, public subnets deep dive. So, connectivity. It has a direct route to an internet gateway, right? In its route table. Now, when we talk about the public subnet, right? So, it has a direct route. That means to access internet, right? It needs a route, or you can also pronounce it route or route. So, both are okay. So, to the internet gateway. So if it gets a route right to internet gateway, that means that subnet is public and it is not there by default, right? This route is not there by default. We need to create it, right? We need to create it. So alright, when we are creating our custom VPC, we need to write in our route table for that public subnet. We need to create this route that says that, okay, if you want to connect to internet, you need to go through internet gateway. And that is what will make that public subnet actually public,
Okay.
right? Yes. So the typical resource, right, that we are launching right inside public subnet are your web servers, right, your user-facing load balancers, right, and passion hosts, right. So web server we know, right, they need internet access, right. Anybody from internet, we want everyone to connect to, right, our web servers. Your load balancers, definitely if it is user facing, or we call them right internet facing also, right, user facing or internet facing load balancers. So for them, right, again you will be launching them in your public subnet, right. And the bastion host, now again we have, right, we also call them jump hosts, right. So from internet, right, say you connect to your jump host, and then from that bastion host or that jump host you connect to your internal resources, right, privately. So it should be right, say internet facing. So for all these requirements you can use public subnet, right. And the IP addressing, how it works for your public subnet. So resources usually require an public IP address, definitely, right, or an elastic IP address to be reachable. So we know that to actually discover any device or any, right, say server over the internet, we need public IP address. Right. So without public IP address, we cannot identify that or locate that, right, particular device, that right on a network. Right. So for that, the resources that we are launching inside public subnet should have public IP address. Right. This is again mandatory. Without public IP, we cannot connect right to that, right, say that particular server or that instance, right? Even or the elastic IP, right? So elastic IP is actually the static IP, right? So by default, say when we are creating our instance, say our EC2 instance, we are getting a dynamic IP address, right? We are getting a dynamic IP address that is public, right? Public, dynamic public IP address. Dynamic IP addresses, right? They can change, right, they can change whenever, say, we stop our instance and we start again, right. So what happens is we release our previous IP, and then we get, right, another new IP, right, when we are starting it again. So that is dynamic, right. But we can also go for elastic IP, right, that is permanent, or right, a static, we call them static public IP. So in AWS, we have, right, the option to allocate, right, elastic IP, and then we can attach that to our resource, so that even after, right, we just stop our resource and start them again, they will have the same IP, the fixed IP, right?